Okay, today we are going to discuss on dealing with material data analysis and interpretation course assignment number 7. Let's go to the first question. So the peak in XRD profile is best represented with a combination of. So this is the representative image of XRD. It's actually taken from one of our data. So for FCC material, we can see the peak is having some broad base with sharp peaks. In order to attain that, if you take the Gaussian, which is this dark color, the black color line, which is having, which doesn't give any broad base in the um, bottom. So here it should be broad base, right? So that is not happening in case of Gaussian. So, but still it can give the best, almost close fit. And if you take the Lorentzian fit, Lorentzian is like it's giving the base as same, base as little broad, but the sharp peak is not attained in case of Lorentzian, but it is also almost giving somewhat. See, if you take these peaks, right, these peaks can be best fitted using Lorentzian. So yeah, Lorentzian peaks. So Lorentzian or Cauchy, Lorentzian is also called as Cauchy. So Gaussian and Cauchy can give the best fit for the XRD profiles. So if you want to fit, and some people use this combination of this Gaussian and Lorentzian. It is called the Pearson 7 functions. These functions have the combination of both this Gaussian and Lorentzian factors. So yeah. So the probability that classical identical and distinguishable particles in an energy state E is given by Maxwell-Boltzmann distribution. So the Maxwell-Boltzmann distribution is like it's a the expression is given by one second. It's an exponential function. So it's given by this way. For phi is equal to a into exponential of minus e by kt. Yeah. Okay, to go into the third question, the given set of data can be characterized into a particular distribution using Cullen-Frey graph. The x-axis and y-axis of the plot represents, actually I have represented the Cullen-Frey graph here. So x-axis represents the square of skewness and y-axis represents the kurtosis. So x-axis and y-axis are skewness and kurtosis, sorry, square of skewness and kurtosis. So in lecture 59, the probability selecting random point when a circle was used to calculate the value of pi. Okay, so here the simply they are asking for if you have a if you have random deviates generated from uniform distribution function using R unif and RD unif functions. The error between the calculated value and the original pi is minimum. Like with generally the error between the error is minimum in case of continuous uniform distribution because it is averaging out a huge bunch of data. But discrete is like it's a discrete set of values, so the possibility for error is little less, sorry, little high in case of discrete and less in case of continuous uniform distribution. So fifth question: consider the following data. This is from a paper. which of the following histograms obtained using bootstrap method correctly depict the data? So in order to obtain some data set, first what we can do is like we can input the data, and we can input the data using C of the name of data. Then we can resample it to 1000 using this n resample to 1000. It generates random data, and calculate the mean and replicate the mean sample data. Then we can plot the histogram. So this way also we can do. There are many other ways to generate the random samples as well, but whatever way you do, even bootstrap or whatever way, the mean should remain same. So based on that we can conclude this problem, because the mean of this is 546 point yeah, 546.6 something. So in this case, if you take the a, right, the mean is falling around between 545. So this is not correct. And if you see here, the mean is falling after 547. This is also not correct. And if you see C, it is mean is falling exactly on 546. This is also not correct. It should be little offset from the 546. So in this case, if you see, it is like closed, it's more than 546. So 546.95. If you find the mean of that, it's also almost right. Let me tell the exact value of the mean. So exact value of the mean is 546.96. So only this graph is close to the that 546.96. So I have generated the bootstrap histogram. This is also coming close to 546.96, 546.96 or 97. Going to sixth question. A well-known method of random carbon dating is used using the process of radioactive decay of C14 atom to N14 atom. In such process, C14 atom decays to N14 atom in 10,000 years. What is the probability that C14 atom will decay to N14 atoms in 5,000 years? They asked what is the probability that the decay can happen within 5,000 years. So for live determination, we can use the exponential distribution function. So probability of t less than or less than 5,000 is equal to 1 minus exponential of minus lambda t. This is exponential distributions equation. Okay, here to find the lambda is a constant. For that, we have to take a ln. The formula for the lambda is like lambda is equal to ln 2 divided by half-life period. So half-life period is they have already given. Um, half-life period is around 5,730, and from this we can find the lambda, and we can substitute the lambda uh, in this equation, and we can find the probability distribution, which is 0.393. The probability of t less than 5,000, 0.393. Yeah. Which R code snippet will give the correct answer for the following question 6? Okay. pause. Yeah, sorry for the delay. Like there was some internet issue. Okay, so we are discussing the seventh question. Seventh question. They are asking what is the correct answer for the question number 6. So snippet will give the correct answer to the question number 6. What is question number 6? We have seen this uh, half-life decay. For this, okay, it's a cumulative distribution. Like this kind of equation means the exponential distribution. We have to find the cumulative distribution till half-life period. So which of the R code snippet will give? Okay, for that, this is general syntax for this cumulative distribution function for a exponential distribution. So for that, Q represents the value at which to evaluate the CDF up to half-life of 5000. The rate is the rate parameter often denoted by lambda of the pre-exponential function distribution. The rate parameter means lambda here. So then lower tail is equal to true means it from whether to calculate the lower tail probability or upper tail probability. If you give lower tail probability true means it will calculate lower tail, which is the default. Otherwise, it will, if you give false means it will calculate the upper tail probability. Okay, so and log dot p is a logical value has to be returned in a natural logarithm of the cumulative distribution function or general CDF itself. So by default it is false, which means like general CDF. If you want, we can enable it as a log also. So here, if we see the uh, previous question, right? Oh yeah, this question. Um, we have to calculate till 5000. So it 5000 is same for all the answers. The rate is 1 by 10,000. Yeah, lambda is like 1 by 10, 1 by 10,000. Because it happens in 1 by t by 1 by t. That is the rate parameter. Then yeah, we don't want it in a log plot. We just want it in a just CDF plot. So log is false or f, whatever you, yeah, whatever you give. So which one is correct means this is C. Select the code snippet that will calculate the area under the curve of a chi-square curve with a degree of freedom 7 in the interval 6 to infinity. Okay. So chi-square distribution is like a little uh, skewed to the one end. So mean is 6, 6 to, sorry, yeah, mean is 6, 6 to infinity. It's like ah, 6 to infinity means this upper tail. This is not, this is the lower tail, this is the upper tail. To find this, what we have to do is cumulative distribution of the chi-square distribution with starting from 6, that's a quantile value to which we have to evaluate CDF like before, whatever we discussed. DF is the degree of freedom of the chi-square distribution. So 6 and DF7 is same for all. Just we have to tell whether it is the lower tail or upper tail. So since we have to find from 6 to infinity, we have to give, sorry, we have to give false. So if it was like minus infinity to 6 means we can give the lower tail. Yeah. Going to the ninth question. Suppose you want to plot the probability density function of a log normal distribution in R with mean 0 and standard deviation 10. Where on log scale, where x-axis range is 0 to 1. Which of the following code snippet is correct? So d ln is the uh, is getting the log normal distribution where yeah, log normal distribution. X is a numerical vector specifying the values at which to evaluate the PDF, which means for what value of x we have to find the PDF. Then mean log is the mean of underlying normal distribution of the log scale, and the standard deviation in log scale, SD log, because these are all the input parameters for this functions, right? So SD log and mean log are the input parameters. Then whether the value should be returned in log or not, for that we have to give log true for returning in log, and by default the log is false. So here if you see, and curve is used for plotting. So a curve is used for plotting the expression, a mathematical expression. So here the mathematical expression is like d ln, the normal distribution generator is the mathematical expression for this. From 0 to 1, it's like kind of cumulative distribution only, but we are generating using given input parameters from 0 to 1, like that. So if you see curve d ln x, mean log 0, SD log 10 from 0 to 1, this is correct. And also by default it is from 0 to 1 only for whatever the curve which we are plotting, right? So this can also be correct. Both C and D are correct for this answer for this question. Okay, for coming to the 10th question, it's similar to whatever we have seen before, but here they have given the mean is equal to 0 and standard deviation is equal to 0.5. How the curve would be? So since it is 0.5, you can see like the curve is not what to say, the standard deviation is 1, it could have been symmetric. Here since it is 0.5, it is not symmetric, and it has the um, variation along the one particular direction. So this is the plot corresponding to the given mean and the standard deviation. So it is generated using this formula d ln dl normal distribution with x I have given what 0, mean log is equal to 0, x I have given from minus 20 to plus 20, and mean log is 0, which is they have given, and SD log is 0, and yeah, from it is varying from minus 20 to 20. That's the x value which I have given, yeah, and obtain this plot. So hope this assignment is clear. Yeah. If you have any doubts, you can ask. If you don't have any other question, yeah, you can wind up this. And if you have doubts, already I have shared the mail with you. You can write to that mail, I can answer.